So in this video, we'll see the electric motor and generator, a comprehensive overview. So here we have given the different types of um, electric motor, electric generator, induction motor, synchronous motor, brushed DC motor, brushless DC motor, synchronous motor, and the smart grid. So we'll see one by one that the heading is given the comprehensive overview. So we'll see one by one. So a comprehensive explanation on the various aspects of the electric motor and the generators, spanning their history, principles of operations, types, applications, and the future tense. So first we'll see the introduction part. Electric motor. Electric motor and the generator. Electric motor and electric generator are the fundamental component of the modern electrical system, playing the critical role in converting the electrical and the mechanical energy from powering household appliances to propelling industrial machinery. Electric motor and generators have revolutionized countless aspects of our daily lives and industrial process. So first we'll see the uh, electric motor. Now, first, before going in the deep explanation about the electric motor or electric generator, we'll see the history of electric motor and generator. The roots of electric motor and generators can be traced back to the early 19th century, where pioneers such as the Michael Faraday and Tesla laid the groundwork for their development. Faraday's discovery of the electromagnetic induction in 1831 paved the way for the modern electric generator, while Tesla's innovations in alternating current system revolutionized the design and the operations of electric motors. So, principle and operation of the electric motor. Electric motor. So electric motors operates on the principle of the electromagnetism, where the interaction between the magnetic field generates a force that produces the mechanical motion. The basic operation of electric motor involves the creation of a rotating magnetic field that exerts a torque on a rotor, causing it to turn. Depending on the type of motor, this rotating magnetic field is generated by either alternating current or the direct current supplied to the motor winding. Next one we will see the electric generator. Electric generators operates on the principle of electromagnetic induction, where the relative motor between a magnetic field and a conductor induces an electromotive force or voltage across the conductor. When the conductor is rotated within a magnetic field, as in a generator, it cuts through the magnetic lines of the force induced the voltage in the conductor according to the Faraday law of electromagnetic induction. So there are different types of the electric motor. We see the types of electric motor. First one is the first one AC motor. In AC motor, we'll see AC motor. AC motor. In AC motor, first one is the induction motor. Induction motor. Widely used in the industrial and the commercial applications. Induction motor operates on the principle of the electromagnetic induction, where AC power is supplied to the stator winding to create a rotating magnetic field that drives the rotor. Next one is the synchronous motor. These motors operates at a constant speed determined by the frequency of the AC power supply. They are commonly used in the applications where precise speed control is required, such as a synchronous motor used in the industry machinery and synchronous reluctance motors used in the electric vehicles. Next one we have the DC motors. Again in the DC motor we have the two types of DC motor, brushed DC motor and the brushless DC motor. Brushed DC motor. In the brushed DC motors, mechanical brushes and a commutator are used to switch the direction of the current flow in the rotor winding, creating rotating magnetic field that drives the rotor. Brushless DC motor. This one is the brushless DC motor. This one is the brushed DC motor. In the brushless DC motor, eliminate the need of the brushes and commutators by rotating the electronic commutation, making them more efficient, reliable, and maintenance free compared to the brushed DC motor. BLDC motors are widely used in applications such as the automotive system, robotics, and industrial automation. Again, we have some specially motors like the like the stepper motor, and the linear motor. Linear motor. Stepper motors are electromechanical devices that convert the digital uh, input pulses into the precise rotational motion. They are commonly used in applications and requiring accurate positioning and control, such as 3D printer, CNC machine. CNC means computer numerical control machines, and the robotic system. Linear motors. Linear motors convert the electrical energy directly into the linear motion without the need of the mechanical linkage or rotatory to linear conversion mechanism. They find the applications in the high-speed transportation system, magnetic leviation, trains, and the precision positioning system. Types of electric generators. We have different types of electric generators. In the AC generator, mainly we are using the synchronous generator, and second one using the induction generator. So what is synchronous generator? Synchronous generator, also known as the alternators. Synchronous generator is also uh, uh, known as the alternators. Synchronous generators produce the alternating current by rotating a coil of the wire that is called the armature within the magnetic field created by a stationary field binding. They are widely used in the power plants, wind turbines, and the hydroelectric system. Coming to the induction generators, the induction generators operates on the same principle of the induction motor that already I have discussed, where AC power is induced in the stator winding by rotating magnetic field. They are commonly used in the renewable energy system such as the wind turbines, small scale hydroelectric generators. Coming to the DC generators, DC DC generators. DC generators, again we have the two types of DC generators, dynamo generators and the permanent magnet generators. Dynamo generators produce direct current by rotating the magnetic coil of the wire that is called the armature. within a magnetic field created by a stationary field winding. They are commonly used in the early electrical system before the widespread adoption of the AC power. Next one we have the permanent magnet generators. In the permanent magnet generators produce the DC using the permanent magnets to create a magnetic field. They are used in the applications requiring the portable or backup power sources, such as the emergency generators and the small scale renewable uh, energy sources, renewable energy system or the sources. So applications of electric motor and the electric generators are, first we'll discuss the industrial applications. Industrial application. So in the industrial application, electric motors are ubiquitous in industrial machinery and equipment powering conveyor belts, pumps, compressors, fans, and machine tools. Whereas electric generators play a crucial role in power generation plant where they convert the mechanical energy from turbines driven by steam, water, or the wind into electrical energy for the distribution to the consumers. Next one, it can be used for the transportation. Electric motors are increasingly used in the transportation applications, including the electric vehicles, hybrid vehicles, trains, and the ships, offering the benefits such as the reduced emission, improved efficiency, and the lowered operating cost. Electric generators power auxiliary system in the transportation vehicles, such as on-board power generation in the aircrafts and the ships. Next one is the renewable energy. In the coming to the renewable energy, electric generators are essential component of the renewable energy system, including the wind turbines, hydroelectric generators, and the solar photovoltaic system. Electric motors are used in the renewable energy application for the tasks such as the tracking solar panel, adjusting the wind turbine blade pitch, and controlling the hydroelectric turbine speed. Fourth one, it can be used for the consumer electronics. Electric motors power a wide range of the consumer electronics and the appliances, including the refrigerators, air conditioners, washing machines, vacuum cleaners, and the power tools. Electric generators provide the backup power in the residential and the commercial setting, ensuring uninterrupted power supply during the outage. So, what are the future trends and developments? So, it can be first one efficiently improved, and it can be integration with the smart grid, electrification of the transportation, renewable energy integration. So, first we'll see the efficiency improvements. So, what is efficiency improvements? So, ongoing research and the development efforts focus on the improving the efficiency and the performance of the electric motor and generator through a advanced materials design optimization and innovative control strategies. High speed motor and generators helps reduce the energy consumption, lower operating cost, and minimize the environmental impacts. Integration with the smart grids. Electric motors and generators are increasingly integrated with the smart grid technologies, enabling the bidirectional power flow, demand response, and the grid stabilization capabilities. A smart motor system equipped with the sensors and the communications interfaces enable the real-time monitoring, diagnostics, and the optimization of the motor performance. Third one, it can be used for the electrification of the transportation. The electrification of the transportation is driving demand for the high performance electric motor and generators capable of delivering the increased power density, efficiency, and the reliability. Advancement in the motors and the generator technology support the development of electric vehicles, autonomous transportation, and the system and the sustainable mobility solutions. Next one, it can be used for the renewable energy integration. The rapid expansion of the renewable energy sources such as the wind, solar necessities the deployment of the efficient and the reliable electric generators capable of harnessing clean energy and integrating it into the grid. Variable speed generators and the grid forming converters enable the seamless integration of the renewable energy resources, improving the grid stability and the resilience. So, in the conclusion, we can say that the electric motor and generators are foundational element of the modern electrical system, driving innovation, efficiency, and the sustainability across diverse industries and applications, and the technology advances and the societal demands evolve. The development of the high performance motor and the generators will continue to play a vital role in shaping the future of energy consumptions and industrial automation. So this is the comprehensive overview of provides a deep dive into the principal types, applications, and the future trends of the electric motor and generators, offering the valuable insights into these indispensable comments of the modern engineering and the technologies.